Welcome to the City of Saco Water Resource Recovery Facility. The facility was originally built in 1971 to treat an average daily flow of 1.57 million gallons a day. Major modifications in 1988 included a new 75-foot secondary clarifier and the addition of 2 new aeration tanks, which allowed the facility to treat an average daily flow of 4.2 million gallons a day, capable of treating a peak flow just over 8 million gallons a day. More improvements were done in 1996 with the addition of another 75-foot diameter secondary clarifier, which replaced the 2 original 50-foot clarifiers. In 2002, the facility saw a dewatering upgrade, going from belt filter presses to a rotary press manufactured by Fournier, and also the addition of a rotary sludge thickener, which is used to thicken secondary sludge from 0.6% solids to about 6% solids before being dewatered. The aeration tanks were upgraded in 2006 to incorporate an anoxic zone for nitrification-denitrification, recirculation pumps, membrane fine bubble diffusers, and 2 new blowers. The Storm King was also installed in 2006, which allows for the treatment of up to 5 million gallons a day of stormwater. The current state of the facility saw its last upgrade in 2009, which saw a new process building, garage, and new yard piping. The staff, which includes a director, deputy director, master electrician, 2 mechanics, lab technician, 2 operators, and administrative assistant, are also responsible for 29 pump stations located throughout the city.
Hi, I'm Stacy Thompson, the Deputy Director of the treatment facility. Behind me is the headworks of our facility. We receive flow from 2 different parts of the city. One from the west side, being via a 24-inch influent line. The other from the east side of the city, which is 2 10-inch lines. To the back left of me is a circular structure where both of those flows are combined into our headworks. This is our diversion structure, or what we like to call here the grassy knoll. What this is the influent coming from the west side of the city, which is mostly combined sewer. What happens here is that there's an automated gate valve. When our influent flow hits approximately 8.5 MGD, this gate valve receives a signal to start to close. And what then happens is the level starts to rise until it's high enough to start diverting to our Storm King for stormwater treatment. The east side of the city comes into the plant via 2 10-inch lines. The west side and east side meet in this structure, our circular structure right here, and then move on to the headworks. The flow is then measured via an ultrasonic transducer, and it cascades over a flat-crested weir. From there, we receive preliminary treatment from our Lakeside, which is the fine screen separator, and also our Grit King, which removes grit.
The Lakeside, our fine screen separator, is automatically controlled through a PLC. The cycle of the Lakeside is initiated when wastewater flows into the open end of the screenings basket, through the bars, and continues along the channel. As screenings are held back by the bars, the free flow area in the screen is restricted, causing the upstream liquid level to rise. Upon receipt of a start signal, the rake arm begins to move. With the rake teeth extending full through the screen bars, the screenings are picked up by the rake and dropped into the feed trough as the arm approaches the top. Screenings are washed and dewatered upon deposit in the feed trough. The screw in the feed trough turns in synchronous with the rake arm, transporting the screenings through further washing zones and into a dewatering zone. In the dewatering zone, the screenings are compressed and the water flows either back down the transport tube or passes through drain holes located in the tube into a dewatering chamber. Screenings are discharged into a container for disposal. The Lakeside is only capable of handling a flow of up to 8 MGD. If by chance we exceed the 8 MGD, excess water flows through a manual bar rack.
The Grit King consists of a hollow, cylindrical vessel with a sloping base and a flat top. Flow follows a predetermined path through the vessel, causing the contents to rotate slowly about the vertical axis, forming a small circle within a large circle. Flow spirals down the perimeter, allowing the grit and sand particles to settle out by gravity. The collection area for the separated grit is located at the bottom of the Grit King. A fluidizing system prevents the collected grit from compacting in the collector area and releases entrapped organics, which rise back into the vessel to continue on for further treatment. A 4-inch submersible pump is located in the bottom of the Grit King, which sends the grit to the classifier. The classifier has a screw conveyor that conveys grit up an incline, out of the tank, and out of the water. Grit falls into a hopper and then is disposed of in our sludge hauling can.
Once flow leaves our Grit King, it enters our primary splitter box. From here, it goes directly into our primary clarifier. The primary clarifier is only designed to handle approximately 5 mgd. In this splitter box, there's a bypass that if it reaches that 5 mgd, it immediately bypasses to our aeration splitter box. The purpose of our primary clarifier is to remove fat, oils, and greases, and approximately 30% of our BOD and about 50% of our total suspended solids. The solids that settle to the bottom of the clarifier, and also the solids and scum that are collected on top by the rake arm, are pumped directly to our sludge blend holding tank for dewatering later on. Once through the primary clarifier, that brings us to our aeration splitter box. The aeration splitter box has 3 influent channels, one being from the primary clarifier, the other being from the bypass of the primary clarifier, and also the return activated sludge from the secondary clarifiers. What we have here, typically during summer operations, we only have 2 aeration tanks online because we maintain a solid retention time of approximately 6 to 10 days. The flow splits evenly in those 2 aeration tanks from this side. During winter operations, we put the 3rd aeration tank online because our solids retention time increases from about 10 to 15 days. And that means that this side would also be online so that flow can be split to the 3rd aeration tank. The main purpose of the aeration tanks is to keep the bugs happy. We do that by supplying them with oxygen and also food in the biochemical oxygen demand. Flow enters the anoxic zone into the aeration zone, where the bugs break down the BOD, and also they break down ammonia to nitrate, nitrite to nitrate. That nitrate is recycled back to the anoxic zone, where it can be further broken down to nitrogen gas. At the city of Saco, we maintain our DO at approximately 1.5 milligrams per liter. Each aeration tank has their own DO sensor, which relays back to a PLC what that value is. Within that PLC, there are control loops that actuate valves on each of the head of the aeration tanks that modulate so that it can maintain that DO. Once flow leaves the aeration tanks, it then is equally split between 2 75-foot diameter secondary clarifiers via this secondary clarifier splitter box. One side is dedicated to one clarifier while the other is dedicated to the other clarifier. Within the secondary clarifiers, the bugs, being full from all the food that they just consumed, sink to the bottom of the clarifier, which then get returned back into our aeration splitter box, and then we are left with our final effluent cascading over the weirs. Both secondary clarifiers have a rake arm, which collect the scum on top of the clarifier. One of our clarifiers takes that scum and it gets pumped back into our intermediate pump station, which then goes back to our headworks for treatment. Once through the secondary clarifiers, the flow combines from the 2 of them where it is dosed with sodium hypochlorite to maintain a residual at the end of our tank of about 1.5 milligrams per liter. It is then dosed with sodium bisulfite because we have a total residual chlorine limit of 0.09 milligrams per liter. On an average of about 1.5 million gallons a day, when both CCVs are online, we have a detention time of about 60 minutes.
I'm James Ferguson, operator at the wastewater treatment plant in Saco. I'm here to talk to you about our dewatering system. We have two forms of dewatering. We dewater our secondary sludge from our holding tank behind me here. We use a rotary thickening drum, which uses a wet polymer, emulsion polymer. We get about 6% solids off of our rotary thickening drum. That sludge is then pumped into our mixed blend tank here, where it's combined with our primary sludge. We pump our primary clarifier for about 7 minutes every hour, and then it also enters this tank here. And we dewater that on a Fournier rotary press 4-drum, which is automated to run off pressure, so we can run when it's not here. It has an automated wash cycle so that it cleans itself up after every run as well. We pump about, I want to say 10 to 15,000 gallons of mixed sludge every day. And we produce about 18 tons every 4 days worth of dried cake solids. Our dried cake solids are usually in the 25 to 35% solids range. After our dried sludge has been put into a haul-off container, it is shipped up to Resource Management Inc. in Holderness, New Hampshire, where it's composted to a grade A biosolid, which can be field applied and used as a compost.
Hi everyone, I'm Riley Cobb. I'm the lab technician down at the Saco Water Resource Recovery Department. To ensure that our effluent meets the Maine Department of Environmental Protection requirements, every day we take influent and effluent samples while monitoring chlorine, pH, and temperature. Chlorine is used to protect the public health by killing the microorganisms found in water, which causes diseases. Too little chlorine will not give adequate disinfection, and too much can kill the aquatic life in the receiving waters. 3 days a week, we are required to run BOD and fecal tests. BOD stands for biochemical oxygen demand, and this is the amount of dissolved oxygen needed by aerobic biological organisms to break down organic material present in the water. The fecal test indicates the presence of fecal chloroform, and the presence of these organisms has the potential to cause illnesses. We take processed samples of all clarifier blankets and return activated sludge, and also sampling our aeration tanks. To make sure our treatment process is running efficiently, we use those samples to run total suspended solids 3 days a week. Total suspended solids testing measures the total concentration of suspended non-soluble solids in the aeration tanks and in effluent discharge. Suspended solids tests are run 5 days a week. This test gives us a visual representation of the particulates that settle out when water is still.
Once flow is diverted to the Storm King at the diversion structure, aka grassy knoll, the stormwater influent sampler begins taking samples, and sodium hypochlorite begins pumping to the Storm King. Flow enters the Storm King tangentially into the side of the cylinder so that the contents rotate gently about the vertical axes. Flow first spirals down the perimeter to allow particles to settle out by gravity. The main flow is then directed away from the perimeter and back up the middle of the vessel as a narrower spiraling column rotating at a slower velocity than the outward downward flow. A dip plate is positioned on the underside of the support frame, which locates the interface between the outer downward circulation and the inner upward circulation. This area is called the shear zone, which allows for further separation. Once flow reaches the top, water passes over and through the screen, trapping solids greater than the mesh size. The water level rises through the screen and the siphon begins to prime. As the top water level is reached, the siphon discharges and the backwash cycle is complete. The solids are washed to the center and discharged through the central overflow pipe. Once flow is registered on the stormwater flow meter, the stormwater effluent sampler begins taking samples and sodium bisulfite begins pumping to the dechlorination structure before being discharged to the river. The solids that have been collected at the bottom of the Storm King are pumped back to the headworks of the treatment facility.
In addition to the treatment facility, the WRRD also maintains 29 pump stations located throughout the city. Each pump station is equipped with 2 pumps, a level controller, PLC, variable frequency drive, and radio for communication back to the treatment facility. The pump stations range in size from garden shed-sized buildings to buildings larger than the average house. The largest being Bear Brook Pump Station, which is responsible for over 25% of the flow to the treatment facility. The pumps operate in an alternating lead-lag sequence, which is dependent on the level of the wet well. All stations communicate back to the plant via radio telemetry and send alarms if there is a trip pump, low level, high level, loss of communication, or if the generator has come on. 16 of the pump stations do have an on-site generator which transfers power automatically if there's a power outage. We have 3 portable generators for the stations without a backup generator in case of emergency. Currently, Saco is going through an upgrade of the last CAN pump station and also converting from radio telemetry to wireless communication.
The Saco WRRD facility utilizes a supervisory, control, and data acquisition system, aka SCADA. Staff can review the live happenings of the treatment facility, pump stations, and make corrections to the process if necessary. The main screen shows current flows in and out of the facility, DO of the aeration tanks, return rates, chemical levels, and even the current rain trend. The human-machine interface, HMI, allows for members of the operational team to make changes to processes such as chemical dosing, polymer dosing, or even starting and stopping equipment. The system also allows for alarms to be relayed to our Win911 software, which phones and emails alarms to the staff. 2 members of the staff are on call during non-business hours at all times. They are able to view alarms and log into the SCADA system via their cell phone, computer, or tablet. If by chance there is a malfunction of the Win911 software and an alarm is not acknowledged, a backup dialer is activated and will phone the deputy director until the alarm is acknowledged. An effective maintenance program, whether it be a software program or on pieces of paper, is an essential part to a successfully operated treatment facility. In Saco, we use a computerized maintenance management system, CMMS, which is a web-based program that contains a database of information about the facility. Within the system, we are able to create work orders, put assets on a preventive maintenance schedule, generate reports, and receive email notifications of upcoming work. As with the SCADA system, the CMMS can be accessed from staff's cell phones, so they are easily able to update statuses while out at job sites.
I'm Jackie, and I am the Administrative Assistant here at the City of Saco Water Resource Recovery Department, and I provide the highest level of administrative support to senior staff and the department as a whole. As of December 2014, Maine Water is responsible for all of the sewer billing. Therefore, I work closely with them to answer questions and assist them with the billing process.
Hi folks, I'm Howard Carter. I'm the director here at the Saco Water Resource Recovery Department. I hope you enjoyed a little video presentation. Now, at the beginning of the show, Stacy went over some of the upgrades that we've done over the years since the plant was built in 1971, whether it's adding extra clarifier capacity, extra aeration capacity, B&R upgrades, or even stormwater treatment. What I'd like to focus on now is where I believe the industry is going in the future. I think you're going to see a lot more facilities focusing on the resource recovery aspect of the wastewater stream. There's some studies out there that shows there's 10 times more energy in the wastewater that we're receiving than we're actually capturing out of that. So there'll be a lot of focus on that, and also on nutrient removal. Even though we went to a B&R process in 2006, I think the state of Maine is going to see a lot more of that. I know Portland and a few other places are planning to do upgrades. And with that, there's going to be new technologies to help with that. There's technologies out there now to capture the phosphates in the water, microbial fuel cells coming out, and a few other things. So it's a very exciting time to be in the industry. In Saco, we are proud of our facility. Our crew takes a lot of pride in our facility and our pumping stations, and I hope this little video was beneficial to you all. Thank you.